So today's video, this is a bit of a follow-up to last week's video where we talked about how you can create custom reusable controls in .NET MAUI. Well, there's kind of another level to that you kind of need to understand if you're going to be working in .NET MAUI, and that's an architecture they call handlers. So in this video, I'm going to explain to you what handlers are, how you use them, how you can create your own in your own custom classes, and yeah, all you need to know about it. So let's dig in. So this is the class that we worked on in the last video, the circular button. And I showed you how you can create your own properties. You kind of inherit from an existing view. And in our class, we're inheriting from the graphics view. And then we added 3 properties to this view that you can then use in XAML. And then we did the bindable property stuff, which we talked about again in the last video. And then we also had these static methods that handled when those properties were changed. And you'll notice that I've commented out that from the bindable properties. And the reason I did that was you kind of can take care of this in a handler. So what I've done, I removed that logic. And then over here in this new handlers folder, I created a circular button handler. Now, what is a handler? Well, essentially, it's kind of a little helper class that .NET MAUI uses that handles this mapper thing architecture. And what a mapper is it's essentially how, specifically in .NET MAUI, how they're mapping an action in the control to the platforms. So for instance, a button in Android is a specific library that the Android, JDK, whatever, uses. And in iOS, it's obviously a different thing. It's completely different code, right? And the way MAUI works and the way MAUI maps these centralized things that allow you to just type button in XAML, it maps them to platform specific stuff through handlers and property mappers. So that's all well and good. We'll talk more about that in a moment, but just to show you, you can create your own in your own custom classes. And essentially what I've done here takes the place of the property changed methods that we did in the last custom class video. So just to talk through that first, we have these 3 methods: map button color, map image, and map is visible. And they have almost the exact same logic that on button color changed, on image changed, and on visible changed do. They have essentially the same logic. The difference is you don't get past a bindable object and an old value and a new value. What you actually do in the handler is at the point this is called, the property is already changed inside of the class. So you don't need a new value and an old value or anything like that. The value is just stored in the property of the class. And you get the class because the signatures of all of these methods are the handler that's calling them and then the class that you're handling. In our case, that's our circular button. So you can just access if button.drawable and you get the drawable instead of doing the bindable object stuff. So a little cleaner, I think, in terms of code. So I'm doing here if the button drawable is a circular button drawable, which pattern matching stuff, then drawable dot button color equals button dot button color. So button.button color has been set already at the point this triggers. And so we just use it as our drawable.button color and we invalidate the button, which then redraws the drawable. Okay. And similar thing on map image. And we're also doing our fade to logic in is visible. So anytime is visible changes, you get a little fade animation. It operates the exact same way as the code in the class did on the property change methods, but now they're inside of a handler. So we've got these 3 static methods. How do we attach them to a property? And the way we do that is with a property mapper. I'm gonna zoom out just a little bit because this is a long guy. So in a handler, every handler has a property mapper and it is of type iPropertyMapper. And then the types it takes is it's mapping the class that's handling the circular button and the class we're in, the circular button handler. So it's mapping a class to its handler. The property mapper is called property mapper and equals new property mappers, the implementation, circular button handler. And we're also passing it something here. We're passing it graphics view handler.mapper. And you'll notice in my custom handler, I inherited the graphics view handler, which there is one. The reason I did that is because I still want it to map all the other properties that are in a graphics view that I don't want to have to rewrite. So drawable, for instance, is one of them. I don't want to go through all the stuff to do the drawable property and all the other properties that we inherited in graphics view. Those were already done already. Let's just take in that code. And in the same way, for the graphics view handler, we are passing in to the property mapper constructor, sorry, it keeps jumping around, the property mapper constructor, we're passing in the mapper from the graphics view handler so that it knows it needs to start at that place. So all of the mapping in the graphics view handler is already in our property mapper. And then in our initialization, we're also adding 3 more to it. So this is how it maps things. It maps a property name. So you can use the name of function circular button dot button color. That is the property name, and it equals a static method, which is the map method. And so you do this for the properties you add, and now you've got a property mapper that contains everything in graphics view handler plus your 3 you've added. So you've got your graphics view handler. And also just to note, you also in your constructor, you want to pass your property mapper. This is a static thing. So when a new version of your circular button handler is created, you pass it the property mapper to its base function. I think graphics view does the exact same thing as this. And I think there's like a view handler base class that they use that eventually creates the dictionary. So if you were to run this code and you looked at this property mapper in memory, you would see like 40 or so different properties all mapped. And that's all the properties that are inside of your kind of class hierarchy that you're using for your custom control. So yeah, that's how you create one. And you may be thinking, well, isn't this the exact same thing as this? So what's really the point? And you're right, it is. I'm not really using it to its full potential here. I will say that there's nothing, I don't think there's much you can do in this circular button handler that you couldn't also just do in the property changed methods that we used earlier. So, and honestly, if I were writing this not just as an example for people, but just as my own code, I probably wouldn't even bother with the handler. But handler is a very important architecture for you to understand because it's all over the place in .NET MAUI. They use it for all the platform specific stuff as mentioned. So if you wanted to do platform specific stuff in your custom class, you could do that in the handler and using the if defs, like if Android do this, else iOS, Mac do this, that kind of stuff. Though I will point out you can do literally the exact same thing in here. So it's not that different. But the cool thing about handlers, I will say, is that they're kind of extendable without creating new classes and things like that. So I will actually show you how to do that so you can extend the handlers for the base controls that are in .NET MAUI, button, label, entry. We'll talk about that in just a second so you can see why handlers might be useful and also might be useful for your custom class. If you were going to create a library of custom classes and for whatever reason it wasn't open source, I don't know, you could put together that library, create all your custom controls. Sorry, I keep saying classes, I mean controls. You put together a library with all your custom controls, you put it out, and then you can provide handlers so that people can augment the behavior in the platform specific stuff in those handlers. So now that hopefully that all makes sense in terms of how you create your own and how they work, because I think it's important. This is an important first step to understanding how they work, because then once you see the code for how you change the mappings inside of the .NET MAUI handlers, like for the base controls, I think it'll make a lot more sense, because I know the first time I saw that, that's how it was explained, was just here's this big long dictionary resource thing and you got to do all this stuff and how does it fire and things like that. It was kind of confusing. But after I made my own, I kind of got it more. It's like, oh, okay, yeah, it's just name of a property equals a function, and that method gets called when the property changes. Easy enough. So, and one last thing just to point out right here. In the constructor for my circular button, I also set the handler property. The handler property is built in. It comes from iViewHandler, visual-element.handler, which Graphics View had as well. So we're getting it from Graphics View, which is inheriting it from Visual Element. So just to note, you do have to set the handler for your class to be an instance of your handler. Okay, hopefully all that makes sense. Let's move on to how you can actually augment the mappers in .NET MAUI so you can change any controls behavior that you want. All right, so now let's look at this example here. This is an example of how to change the mapping of existing handlers and their mappers inside of .NET MAUI. And this actually comes straight from the Microsoft Docs, which I'll link in the description below, along with a few other resources that I think will be pretty helpful for this. So basically, you can call this MAUI.handlers entry handler. So what we're modifying here is the entry control. So like, text entry, and there's an entry handler, and you can grab its mapper and then use this method called append to mapping. And there's 3 types. There's prepend to mapping, there's modify mapping, and then there's append to mapping. So prepend and append, you can probably figure out what those do, but basically prepend to mapping will insert your code to kind of run before all the other mappers get evaluated. Append to mapping does the same, but it runs at the end. And then modify mapping is you can pick a specific property to change all of its code. So in this case, we're doing append to mapping. We've got a key. The key, I don't think for append and prepend really matters that much. You can call it whatever you want, and it's just gonna run it no matter what. Obviously, if you're doing modify mapping, I think you would need the exact name of the mapping. And then you pass it this lambda function, this anonymous function, and you're passing a handler view. And then in here, you're doing just platform specific code with these if defs. If Android, we do a specific thing. So the special thing about handlers is that they expose this platform view property. And what it does is it gives you kind of platform specific code that you can call. So for instance, in this case, what this code wants to do is change how the entry is focused when the view comes into view, the entry. So if we're doing Android, what we're going to need is handler.platformView.set select all on focus. True. That's the Android specific way to do this. For iOS and Mac Catalyst, you have to call platformView.editingDidBegin, and you give it another anonymous function, and you do handler.platformViewPerformSelector, and then you do this Objective-C runtime class .selector select all. No, I wouldn't even pretend to know exactly what this is doing. I don't know iOS specific code very well, but this is kind of out of the docs from Microsoft. And yeah, so like you can see here, you're calling like Objective-C code, or the .NET wrapper for it in here, and that's if you're doing iOS or Mac Catalyst, if you're compiling for those, and if you're your build target. And then if we're doing Windows, then it's similar. We have platformView.gotFocus, giving an anonymous function, and doing handler.platformView.select all. This is basically just a bunch of platform specific code that you can put into the entry handler mapper. And now at the end of when your entry is updated or whatever, this code will run at the end of all that because you appended to the mapping, and whatever platform you're using, that specific code will execute and it will do the thing you wanted it to do. So hopefully this helps a little bit in terms of seeing how handlers and mappers are powerful. For one, they expose this platform view, which gives you a lot of code that you can mess with in terms of creating platform specific things. It's actually pretty nice to use. And you can find more information in the docs about what all platform view can do, just the tons and tons of different stuff. Obviously it's platform specific. I'll also say that these entry handlers, and I didn't really talk about this a moment ago, but most of the time you create these as a partial class, and you'll do like a base handler class, and then you'll do a circular button handler android.cs or ios.cs or whatever, and you'll do partial classes of this as well, but have the Android specific code in that one, the iOS specific code in the other. And if you look in the .NET code base, you'll see the same thing. Special to note that this is kind of a static change of this code, and so anywhere you do this, it'll just be globally true. So in our case, all entries that are instantiated after this point will have this code in it. And I don't know where the best place to put this is. I mean, if you put it in your Maui program.cs, it'll guaranteed run at the beginning and you'll be good to go. Yeah, there's probably a good place, like a standard place to put this. I would probably put a bunch of them in like a method and maybe call it in here, but either way. So just to note that wherever this runs, it'll be globally true for all your entries. As things kind of instantiate afterwards, they'll all have this appended to the end of the mapping. All right. With that out of the way, I wanted to give just a little bit better of an example in terms of a custom handler that you could write. There's an example in the Microsoft docs that I think does a very excellent job of why architecture is very important. And it actually takes the example of if you're doing a video view class. Obviously, video is something that's going to be very platform specific. iOS will do it differently than Android, will do it differently than Windows. And all of these things will have different APIs and all this stuff. And so handlers are a great way to kind of tackle that problem and give you the ability to write platform specific code and kind of package it up in a nice little package, and then also give people the ability to extend it. So let's just look at those docs real quick, and because I just want to talk you through that example so you can kind of see where this could go, because I think it's an excellent example. So let's do that. Okay, so here is the Microsoft Doc example that I was talking about. Obviously, again, it's linked in the description below. I think this does a very, very good job of talking you through basically all the stuff this video has been about, and kind of walking you through when you would kind of have to do this with handlers. So again, what they're doing is they're creating a video control that's kind of, let me zoom in a bit, a video control. And as mentioned, that would be very platform specific. So they want this control to do two things: play a video from a URL, play a resource embedded in the app, and play a file on the device's video library. And it kind of talks through what it looks like, etc. And here's kind of the architecture that they're using. So this is the platform, the cross-platform control video. And then they write handlers for Android and iOS, and then they have this Maui video player class. And yeah, it's like the native side of things. So if we scroll down here, this part right here talks you through the steps that you would need to do. And it's a lot of the things we've discussed in this video and the last. So they create a class for the cross-platform control. That's, in our case, that was the circular button class, and that kind of gives the public API. Then you create the handler class, you create the property mapper that we discussed. You can also do a command mapper, which is a mapper of commands to actions. So we'll talk about that in a moment, but that's another thing that wasn't in the custom circular button mapper. And then, like I discussed, you can do partial classes for each platform to kind of separate the code, which is a little nice. That way you don't just have 1,000 if-defs. And then you register the handler using the configure Maui handler and add handler methods in your app's Maui program class, which we'll talk about in a second. So here's the code they use. So again, they have the bindable properties. They have these different properties here. They have autoplay, etc. And then here's their handler. So they're using if-defs in the using statements to determine if platform view is using video demos.platforms.android.maui video player or Microsoft UI XAML framework element, that kind of stuff. So they're using the if-defs in the usings to make platform view a specific thing, which is kind of cool. And then they create the property mapper, which is, it looks exactly like what we did. It's you're taking the name of a property and you're mapping it to a method. So pretty straightforward. It talks about what a property mapper is, all this stuff. And then the command mapper, which is a thing I wanted to talk about. So this video class has these actions, these commands, and they've got a command mapper, which is a of type command mapper. It's mapping video to video handler, just like property mapper. And it's taking name of video.update status, video.play requested, pause requested. And it's mapping it to a function inside of the handler as well. And you would do this because obviously the code to pause in Android is going to look different than the code to pause in iOS because they're completely different APIs. It's a pretty convenient way to kind of encapsulate that code as well. So scrolling down here, and then they walk through, this is what I was discussing. You can do the partial classes. So you can do videohandler.cs as a partial class, and then do videohandler.android.cs or .mac iOS CS, .windows CS to kind of separate that code out and prevent you from having to do 1,000 if Android, else iOS, whatever. Okay, and another thing I want to discuss was this connect handler and disconnect handler. These are invoked to kind of, connect handlers. So you can use this to, for instance, if you're using Android, you do base.connect handler platform view, and that platform view is specific to Android. So you'd have to connect the handler, disconnect the handler. That's how you use the partial class and inject it in, basically. I really wanted you to just be aware of that. Okay. And yeah, I think, you can scroll through here, the rest of this as well. It has a lot of really good example code. Found it pretty helpful when I was trying to figure this stuff out. And honestly, it's like a perfect use case for why you would need this stuff because, again, very platform specific. So you can really take advantage of that platform view from the built-in handlers and do all kinds of stuff. It's a very long example, by the way. Don't get sick, but I'm going to do this and show you. There's a lot there. So great example. If you like reading, there you go. You're on YouTube, so you might just like videos. I don't know. But at the very least, if you're just looking for information, here's a lot of it. So you can learn to your heart's content about videos and handlers and how they did the platform specific stuff. So Okay, I hope that all helped. I hope you kind of get what handlers are, what mappers are, how they connect together. Like I said, when I was looking for all this information, I had trouble because every time I wanted to know what the heck's a handler, what the heck is a mapper. I mean, I get the general idea of it's a dictionary and there's properties and stuff mapped, but it was just this big long string of stuff, and then there would be some platform view stuff, and I'm like, okay, how do these work under the hood, that kind of stuff. And a lot of learning about this was digging into the .NET MAUI source code, because these things are all over the place. And yeah, so it's very important to understand. It's very important to understand how you can change the built-in things. It's kind of a nice way to make them extendable without having to write a new class necessarily. And obviously, if you're creating your own class, you can create your own handlers too, and map properties to actions that way, map commands to actions that way, and kind of keep the code clean, keep it encapsulated, keep your source files small, that kind of stuff. I have some other resources that I think will help if you want to dig in further. I found a few really good blog posts. The blog post I mentioned last week from Pedro Jesus on creating customized controls talks about handlers in there as well, so you might go back to that one as well. But I'm going to stick a bunch of resources in the description below to give you further reading to kind of hopefully help you get a little more advanced in terms of handlers. But in general, I think that's kind of it. You could probably learn some more stuff from looking at the .NET MAUI source code and see how they did certain things. Or, I like to look at GitHubs from people who work at Microsoft or work on .NET MAUI, because obviously they're going to be very up to date on how to do this stuff, and they're doing some really advanced stuff oftentimes. So you can always learn more about this stuff. But hopefully this video helps, and I will talk to you guys next time.